Well, my name is Lorena Muñoz del Campo. I come from Chile. I work in sustainable finance and life cycles, and I will be the chair of this session. My co-chair couldn't make it to Switzerland. So today we will have 6 presenters in 2 slots. Each one will have 8 minutes plus 2 minutes of quick questions. And then at the end of each slot, we will have a 15 minutes discussion, conversation, and then the second slot. That's the whole idea. So our first presenter is Taira Goga from the University of Cape Town in South Africa. Her research paper is development of a life cycle-based sustainability analysis framework in application of the South African plastic value chain. I used to work in plastics in Mexico, so it's really interesting. The floor is yours. You have your 8 minutes.
Hi. Hi, good day to everyone. Thank you to the chair for the introduction. As mentioned, my name is Tahira, and today I'm going to be presenting my research. It's around the development of a life cycle-based sustainability analysis framework, and we've applied it to the South African plastic sector. So just a bit of background. This is a timeline, and I don't have a pointer, but it's fine. I've tried to summarize the key developments in the South African regulatory space. So right at the beginning, there's the NWMS that introduced the concept of circular economy. And then we moved on to the South African Plastics Pact and also the EPR regulations that spoke to an increased recycling rate and increased collection rates. Something about the EPR regulations, it actually mandated producers to produce life cycle assessments for various plastic products. Now, bearing the above in mind, there was research that was developed complementing this, starting at the top 2020. So there were LCAs and LCSAs that were created and developed, first of all, on a product scale, so looking at carrier bags and straws, and thereafter in 2022, going a step further and moving on to the national scale. So bearing the above in mind, the aim of our particular research was to create this sustainability analysis framework, and we've used it to analyze both circular and decarbonization strategies for future models of the South African plastic sector. In terms of the methodology, we used the reference case, so that was the current business as usual case in 2018 to sort of develop the baseline model as well as mitigation strategies. There were 3 mitigation strategies that we analyzed, going in order from top to bottom. We have the improved end-of-life management. So this spoke to the increased recycling rates and increased recycled content that's mentioned in the targets. Secondly, it's not that clear, demand moderation. So that spoke to the shift from single-use plastics to reuse. And lastly, the decarbonization of the energy mix. So this is basically, what does the reduction in coal-fired power, what impact does that have on the South African plastic sector? And to undertake this analysis, we've used a combination of material flow analysis and life cycle assessment. The MFA results actually feed into the second stage of the LCA, that is the inventory analysis stage. Okay, so this is basically the system model or system map of the South African plastic sector, represented in the form of a Sankey diagram, where the width of the arrows represent the degree of impact. Unfortunately, due to time, I can't actually go into all of the results, but I think it's sufficient to mention that from this MFA, we actually get a series of indicators. So the circular economy indicators that we analyzed, and this is informed by literature, is recycled content. We have the 2 forms of recycling rate, so the input and output recycling rate. And lastly, we have the collection rate. And then from the LCA side, the additional indicators that we've analyzed, environmental indicators, you have climate change, water use, plastic persistence, which is a fairly new one. And then in terms of socioeconomic indicators, we're looking at job opportunities. So this is just a snapshot of the results that the tool can generate. And I'm not going to really go through all the numbers. I think one that is quite easy to interpret is the recycled content. So this is the amount of recyclate that is in your converted product. And if business continues as usual, if we don't implement any mitigation strategies in 2025, our recycled content will basically be less than 20%. So on the right-hand side, I've done an expansion of the carbon footprint. Just one thing to mention here, the total GHG emissions of the South African plastic sector is listed as 18.7 megatons. So this is basically what does the sector emit on an annual basis. Just to give an idea of the scale of that number, it's actually equivalent to the annual emission load of some small countries. So it might seem small, but it's actually quite big. So just further disaggregation and expanding of the carbon footprint, you can see that polymer production, it's shaded in blue, is actually about 2/3 of the impacts. And this is primarily due to the production of local polymer, because in South Africa, our monomer production is actually a byproduct of a cold to liquid process. In terms of end of life, you can see that self-help disposal, not surprisingly, actually has the greatest impact. And this is due to the incidence of open dumping and open burning, particularly in rural areas. Okay, so I've shown a snapshot, and the second sort of purpose or function that this tool can serve is if we take a selected indicator, and I focused on GHG for now, we can actually create a forecast, and this is to see how a strategy or a combination of strategies performs over time. So going from 2018 to 2025, we can see that if things don't change, it will result in an increase in about 2.2 megatons of equivalent carbon dioxide over the 7-year period. However, if we combine all the strategies that I've mentioned, we will actually see a reduction in 2025. And if we continue with those, with the mitigation strategies, you'll see in 2035, the reduction is actually about 40% lower than what it is in 2018. So I think that's a fairly substantial reduction. Okay, and so in terms of an additional indicator, due to the South African waste management sort of space and the fact that we have our unique waste management options, it was decided to actually analyze an additional indicator or indicators that would be leakage and persistence. So leakage, and you might have heard yesterday's presentations on sustainable plastics. It's defined as the material that is basically leaked into the environment that is untreated by your various waste management options. And then going from leakage, so leakage would be an inventory flow going into environmental impact. That's actually, you're just multiplying it by a degradation rate. And in terms of the trend, sorry, I don't know what happened to my table. In terms of the trend, you can actually see a similar trend to that of GHG. Basically, if we sort of implement these strategies in concert and in combination, we can see a reduction to levels below 2018. So in conclusion, as demonstrated, this methodological framework or this tool has the capacity or the capability to, first of all, analyze key indicators, both material and mass-based, as well as environmental and socioeconomic indicators. It is able to model interventions in separate scenarios and also in combination, and we are able to track system performance over time. The results show that combining both the circularity as well as decarbonization strategies can substantially reduce impacts to that below 2018. This is showcased by the fact that some improvements can be seen as early as 2025, and this also correlates with local and international studies. Thank you.
Thank you very much. You can see it now. So if we have quick questions, quick questions, someone have a quick question? Like, we will be having 2 minutes of quick questions. And then after the first lot of 3 presentation, we will have 15 minutes of a conversation, I must say. So, no question at all? No? I have questions. A quick question. You know, as I said, I work in Mexico from 2015 until before the pandemic in just implementing plastic recycling. Of course, the scenario was different. You know, as in Mexico, they say always that they are too far from God and too close to the United States. So even Mexico export Mexicans and other Latin American people to the United States. The United States export waste as raw material for recycling to Mexico. So the plastic issue was really interesting. The increase of this waste is about 20% per year, which is 30,000 tons a year. And I'm interested in the socioeconomical indicators. One of the disposal they used to have over there is poor people, poor families will take the plastic and use it with energy purposes, then burn it to cook, burn it to warm themselves. Is it the case in South Africa?
Thanks for your question. So we don't actually have waste to energy commercial facilities. It actually makes up about 1 to 2%, maximum 2% of the waste that's basically treated, and that's why I haven't included it in the Sankey diagram. What I have included in terms of the socioeconomic indicators is you'll see that the indicators in terms of full-time jobs. So I've looked in terms of recycling. Obviously, we have a big informal recycling sector. It's made up of waste pickers. And that we've done that conversion into full-time jobs. So that is the one component of the informal sector that we've obviously tried to integrate.
Okay, and did you use also the carbon social cost in order to see how it will impact in the country economy, for instance, like in reducing the cost of the NDC or something like that?
So unfortunately, it's just time dependent and resource dependent. So I wanted to add in one economic indicator just to balance it out. But so what I present is actually a simplification. The decarbonization strategy is actually 2 parts. It's too complicated to go into it in 8 minutes. So short answer, no, I haven't looked at the economic indicator. Part 2 of the PhD, which has already been accepted, we'll probably look at that and more into the social impacts as well. So probably a full LCA. Yeah.
Oh, thank you very much. I don't know if someone else has a question. No. So thank you very much. Maybe you can stay over there and wait. And now we will be having, I took the pictures. Jasmine Matsitja. Yes, sorry. And her research is life cycle assessment and cost for biocarb production from palm oil and rice waste for soil amendments. So the floor is yours, Jasmine. You will be having 8 minutes and 2 minutes for quick questions. You can walk or stay, I don't know, as you prefer. Do we have Jasmine presentation? Yeah. Okay. Yeah,
Hello?
of course. Of course, you can sit down and then you come back at the end. Don't worry.
Hello, good morning, everyone. Thank you for being here. My name is Jasmine Mastisha binti Sarudin. I'm from the University of Manchester. I'm currently a third-year PhD student. My research is about negative emissions technology. And today I'll be presenting one of the technology, which is biochar in terms of sustainability assessment, which is environmental and also economic. Okay, so first, let's dive into the background why we actually need negative emissions technology. It's because of the climate change. So just to give you a quick statistics, Last year, we emitted 54.6 billion tons of greenhouse gas. So 68% of it comes from CO2. Just to give you a quick idea, this is equivalent to 1/3 of a UK if it's a forest burn. So that's a lot. It will drive the global warming as it increase the CO2 concentration in air. Just to give a quick what happened in the future if these emissions continue, it will increase the global temperature by 3.2 degrees Celsius, which is 1.2% more than what the Paris Agreement target. For the past few years, the emission has been the same, which shows that the current reductions efforts are not enough. That's why we need negative emissions technology. Negative emissions technology is something that take the carbon dioxide out from the air and then we store it somewhere. It can be soil, ocean, or it can be a geological storage. So today I'll be focusing on a biochar. Biochar captures CO2 during the plant growth. So the carbon dioxide is absorbed by the plant. And then when it's turned to biochar, it becomes stable carbon. And then we apply it to soil, the carbon stays there for like 100 years or more. It could be up to 1,000 years, but I'll just assume it's 100 years to be conservative. I'm focusing on Malaysia today. Why we're focusing on Malaysia? It's a developing country because most of the negative emissions technology, they're focusing on a developed country, which if we focus on a developing country, we can tap into some certain potential like abundance of agricultural waste, and it can serve as an effective waste management solution too. Biochar, when applied to soil, has different other benefits. So as I said before, the stable carbon will serve as a like a carbon sequestration, so it will become stable in the soil. And it also has some additional benefits such as fertilizer reduction, improving soil fertility, and also water retention. So my research is the first comprehensive environmental and economic assessment of biochar production for soil amendment, because previous research has never considered more than 10 impacts in terms of the environmental. This is one of the first sustainability assessment of negative emission technology in Malaysia, because I published my first paper on bioenergy with carbon capture. So this is the second case. And we have considered 5 different feedstocks here, which is palm fronds, fibers, empty fruit bunches, shells, and also rice straws, as these are the most abundant feedstocks in Malaysia currently. My research objective is to conduct the environmental and economic assessment, to compare these different feedstocks and pyrolysis temperature, and also to analyze the system hotspots. So what are the methods we use? First, I use process simulation, which is Aspen Plus, to get the data, because currently there is no large scale biochar like emissions profile. The data are very scarce, so I had to assume it's somewhere. And then I use life cycle assessment and life cycle costing methodology. These are is the system boundary. As we can see, it includes from biomass acquisition to biochar spreading. So biomass acquisition include cutting for palm fronds, cutting and drying and then shipping. And then for the rest of the palm oil feedstocks, it just been collected directly from the oil palm mills. For the rice straw, it includes harvesting, straw baling, and also transport. It then is transported for 100 kilometers to the facility where we have biomass pretreatment. In this pretreatment, we have screening and also grinding. Screening is to remove the impurities such as stones and metals. And then grinding to reduce the size for it to be ready for the pyrolysis process. The pyrolysis process is where we heat the biomass without the without the presence of oxygen, so that it becomes stable. It's like making a charcoal. And then we also include plant construction, biochar transport, and then spreading. Spreading, we include different benefits. So carbon sequestration, fertilizer reduction, and soil and soil emissions reduction. We analyze it in terms of 1 ton of CO2 removed. So here are the results. As we can see here, the results are net negative, which shows negative emissions has been achieved. It's come from this carbon sequestration in biochar. So as we can see, they are all a bit the same, which indicates that all feedstocks here are suitable for application. However, the best feedstock here is fiber and shell, slightly more savings. The dark blue bar here represents the highest contributor towards GHG. All right. I'm a bit nervous, we don't have time yet. Okay, so they are the big contributor. However, as we can see here, other environmental impacts are positive, except for ODP. So this one indicates that although GWP is negative, there are other impacts that are positive as well. Moving on to the cost, it's the same trend. So higher cost at lower temperature, because lower temperature produces the lowest yield. That's why we need more materials to capture more carbon. Then the lowest cost here is fiber and shell as well. And then moving on to the conclusions, this project has shown net negative impact with a cost 61 to 208 ton per CO2 removed. It shows here that it has some cost, so we need some incentives for it to be moving forward, such as the sale of biochar or some government incentive. And then the system with shell perform best environmentally, and it has potential sequestration of up to 54% national emissions of agricultural sector. So what we will do next is we will compare the results of biochar here with other negative emissions technologies such as bioenergy and also forestation and other entities. So that's all. Thank you.
Thank you very much. So are the questions? Wait, you can sit. You like to move. I like to move in conference too.
Yes.
So, yeah.
Hello, I am Jacques from the Research Institute for Organic Agriculture in Switzerland, and we are also working on compost on palm oil residue. And one question I have for the use of the charcoal the biochar you are producing. One first very important point is the quality. Also for the HAP, the organic pollutants which are inside, and they are coming if you are too low with the production of the biochar. And also biochar alone in the soil is mostly not so good for the cultivation, because it's not so rich in fertilizer and it immobilized. So you have first to charge the biochar with fertilizer. How do you do it, or do you want to do it?
Thank you. That's a very interesting question. So in my analysis, it's mixed biochar with a normal fertilizer as let me show you. So the system boundary here shows fertilizer reduction. This is actually in terms of NPK. It will replace 10%, 5%, and 5% of the normal NPK applied to the soil. So it won't replace all of them.
But don't you think it could be interesting to make biochar with a part of the waste from the palm oil with the rest to make compost and to combine it to after bring to to the plantation, for example.
Okay, that is one of the keys as well, which could be expanded in this. However, we need to consider the impacts of composting as well. So that compost will need to be added into the system boundary. So currently, I'm not considering that as one of scenario, but it could be added in the future. Thank you very much.
Another question? Yeah.
I think it's his first time.
Can you hear me? Oh, yeah, okay. I was wondering what is the energy mix you use for the heating at 600 degrees and how does it change based on the vector you use?
Thank you very much. So the energy mix currently in Malaysia is highly fossil fuel mix. So there are coal and also natural gas. So that's why in my results, the main system contributor is pyrolysis, which contributed from the electricity to heat that. Yeah.
So if we have time for one quick question, so yours,
Thank you very
and
much.
then the discussion we can postpone it to the end of the session.
Okay.
Yeah, hi. Thanks for your presentation. It's interesting to see the reduction of CO2 emissions. What I wanted to ask was, generally in literature, biomass is generally criticized because it has a negative impact in terms of land use and water use. So is that something you would consider in further analysis just to see where the shifting of burdens lie? Thanks.
Thank you very much. Land use, I have not considered in this because we have used the waste that are actually available. So it comes with zero burden. So these ways I factor in all the potential use, such as making mattresses, making other things, burning it in oil palm mills. But here is just the waste that are otherwise be left on field or will be decomposed. Yeah.
Okay, thank you.
Thank
you
you
can
very
sit. Thank you very much. Now we have the last presentation of this lot. This is Loai Radvan from World Resource Forum. He will be presenting life cycle sustainability management in SMEs, learning from electronics in the developed economies. So the floor is yours, and you will be having 8 minutes starting now.
Can you hear me? Okay, perfect. Yeah, good morning, everyone. My name is Loai Radwan from the World Resources Forum. I hope you're enjoying the conference. Yeah, and today I'll be presenting our work on life cycle sustainability management and small and medium enterprises, our learnings from the electronic sectors in developing economies, focusing mostly on Latin America. So a bit of background, life cycle sustainability management, it's a business management concept that aims to improve the products and the services, while at the same time enhancing the sustainability performance of the businesses across its value chain. This concept was supported by 2 publications. The first one is the Life Cycle Sustainability Management Business Guide, which was published in 2007. And then we also have the Eco-Design Implementation Process Manual, which was published in 2017. And basically, it provides an implementation guide to service providers or consulting companies to take SMEs through an iterative process considering of 6 phases to implement eco-design or eco-innovation. So a bit of background on SMEs globally and in Latin America. So globally, SMEs contribute around 25% contribution to the GDP is within developing countries, while around 75% is in the industrialized ones. On the other hand, in terms of job creation, we have around 61% of the jobs created are within the developing economies, while only 39% are within the industrialized economies. And if we're focusing on Latin America, we see that around 99.5% of the enterprises in Latin America are actually considered micro, medium, or small enterprises, while only 0.5% are actually big enterprises. And this shows how much SMEs are influential, especially in developing economies. So the aim of the work was to identify and assess the environmental and social hotspots in the assembly of components for electric and electrical equipment specifically in Latin America. So we all know that high-tech electronic components like the batteries and the PCBs, the CPUs, are mostly manufactured in Asia and China, and are then exported to Latin America for the assemblers, which are used to make electrical equipments like laptops, refrigerators, and medical devices. And so we did 6 pilots in Latin America with companies like PC Check, Mabi, Consortium of Climatization, Compumax from Colombia, but we also had companies from Peru, like Mediasonic and Group Intersys. And as we can see, all of these companies, they are refurbishers, they are retailers, they are assemblers, they are producers, but none of them work on the upstream of the supply chain. And so their work is mostly focused from the production stage to the recycling stage, but none of them work on the manufacturing of the electrical components, none of them work on the extraction of the raw material, etc., which are typically happening in Asia. And so for the scope of the assessment, we excluded the extraction and transportation stage and focused more on the downstream part, which actually these SMEs have influence or control over. And so the key environmental hotspots that we found. Firstly, there is an impact of human toxicity. This is mostly due to the chemicals of concerns that are being used in the electronic devices. These include like the hydrofluorocarbons, which are used in temperature exchange components. But we also have the brominated flame retardants, which are used in plastic cases in many electronic equipments, like the mobile phones, laptops, etc. And these impacts were very apparent within the production stage, but also within the recycling stage, where the workers had to deal a lot with these components and with these devices, and they were not aware of how hazardous they were and the impacts they have on the human health and on the environment. We also have the impacts of waste packaging, which was used excessively within the production stage and also within the retailing stage, because producers tend to protect these electrical equipments with a lot of packaging to protect it from any damage that happens. And so there was a huge amount of, there is excess amount of packaging that was used. We also see the impacts of depletion of critical raw materials, the critical raw materials like cobalt, like lithium, which are found in batteries and in PCBs, which are used in electronics devices. And then there's, of course, the ecotoxicity during the recycling stage, which is typically due to the uncontrolled end-of-life processes like open burning of cables and electronic equipments, which had an impact on the environment. In terms of social hotspots, we found hotspots like the health and safety issues, which was also in the production stage, but also in the recycling stage. This is mostly because also the chemicals of concern, which the workers were not fully aware about how hazardous they were and how impactful they were on their health. We also find impacts on the local supply relationship with the local suppliers within the recycling stage, within the recycling phase, which were treated unfairly. Other impacts, which is critical hotspots, included the retailing stage, which was the data privacy of the consumers. So the retailers were not aware how to deal with the data of the consumers and what to do with the data. They were not knowledgeable, like, okay, what do we do about the data privacy of this? So this was a social hotspot that was that presented a huge issue there. But on the other hand, we also have positive social hotspots, and these include, for instance, the job creation. Although all of these companies, they work on a downstream part of the supply chain, like assemblers, refurbishers, remanufacturers, etc. Yet there is a huge potential for job creation. The sector is growing very rapidly, and more people are working in these areas. We also have the positive impacts from the technological developments. Other impacts include in the use phase, for instance, the enhanced working and living infrastructure from using of these electronics and electrical equipments. And so it's important to know that when it comes to the maturity level of these companies, all of the pilots fell within the scope of 2 and 3 level. That means that they were classified either as qualified or efficient, meaning that their span of control or their influence lied mostly within the project level or within the enterprise levels. These companies were not yet, for instance, level 4 as effective or adaptive, where they had an influence or control over their whole supply chain or impact over the whole society. And this is something that we tried to increase the maturity level of these SMEs to help them to have a more control over the value chain, to have an influence on their foreign suppliers or their external suppliers from Asia. And so impact and also level 5, where they have an influence over the whole society. And so the key learnings from the work, firstly, is that the electronic sector is a large and emerging successful sector within Latin America and the Caribbean. And a lot of people are starting to work within the end-of-life stages in the formal and the informal activities. It also has a huge potential for job creation, where more and more people are working there, and a huge potential for technological development. Suppliers from Asia are out of the sphere of influence of these SMEs. These small companies in Latin America, they don't have an influence on their suppliers in Asia. In many cases, the interviews trying to be conducted with the suppliers from Asia, like very little data was provided. For instance, the material data sheets were like very scarce information was provided. So it was it was a struggle to have an influence or control over these suppliers. These companies are mostly assemblers. There's a good level of compliance with regulations, including the emerging extended producer responsibility legislations. There's also a lack of understanding of the chemicals of concern that are included within the electronic devices. They're not fully aware of how hazardous they were, how to deal with it. They need training and they need proper hazard and safety management processes. The retailers and the producers are blinded towards the excessive amount of packaging that's generated within these electronic devices. And finally, they are unaware about the data privacy issues that exist within these devices. Thank you for your attention.
Thank you. So, is there any question? Yes. Go on.
Hello. Hi.
Yeah. Hello.
Thank you for your presentation. I'd like to ask about what do you think is the most important impact? So as you mentioned, there are human toxicity and there also must be global warming potential associated. So what do you think is the most important impact category? And also what is the highest contributor towards that impact?
Okay, so what I think it's, are we talking in terms of environmental impacts or social?
Yeah.
Okay, so I believe like the human toxicity, people are not aware of the hazardous chemicals that are involved within these electronics. I think that has a huge damage also in the social part, which is the health and safety of these workers or the people working in the sector. I think that's I think the most critical one. If we would assess, giving like many of the end-of-life processes, we have also to consider that there is the informal sector where many of these electronics are just burned in open air, open burning, and so on. And this is quite hazardous and toxic in many cases for the workers.
Hey, so I have a rather long question for you. So I will reserve it for the discussion.
Okay.
Is there any other question?
Yeah, there's one question.
Go on.
Me to raise a quick one.
Yeah.
How was the social assessment done? Like, was it like you did it with interview mainly, right?
Yes, interview. The project is not only WRF. There is, of course, partners from Colombia and from Latin America. It's a group of different stakeholders and partners. And of course, it was done during an interview. We do a stakeholder interview, and we used mostly a life cycle thinking approach to it. And we built the life cycle inventory. We did not do an LCAs because this is not an LCA. It's an LC, like it's a life cycle management approach to it. But we had the inventories and we did stakeholder interviews with companies in Latin America. We also tried to do it with suppliers from Asia, which was not, yeah.
So maybe this representative could go there and we have a relaxed and quick conversation of 15
If I
minutes.
just could say one comment. Yeah, we have the eco manual electronic supplement with the pilots and everything with a QR code if you want to see it. I'll just gonna put it. Yeah. Thank you.
Now I can have my question.
Yeah.
So thanks. Just it, we will have a 15 minutes exchange, relaxed conversation. If anyone have a longer question that maybe cannot be reached in 2 minutes, but we have 15 minutes left for this 3 presentation, and then we will having the next 3 presentations. My question is, you know, Lo, I come from Chile. We have more 40+% of the reserve of lithium in the world. Right now, Chile is at 20% of the market of lithium, followed by Australia, China, and Argentina. So in the extraction point of view, you are facing a scenario where 57% of the market is in Latin America. It's Argentina and Chile. And maybe that questioning, why didn't you envision that? I know that maybe the batteries come, all of them from China, but maybe we should be following and maybe building a South-South collaboration in terms of Latin American countries producing lithium, extracting and producing lithium for the world market. And maybe, I don't know, something could happen on that side of the analysis. Not always everything comes from China or whatever else. What do you think about it? You need to switch it.
Okay. Yeah, I completely agree with what you said. I know that like lithium reserves in Chile, which are then exported typically like to China or other parts of the world. I think there's a huge potential in Latin America, also in Africa, where like many of the metals and many of the with the elements that are used then to produce the electronic equipments are produced. And I think there's a huge potential for that side. It just, when we were doing the analysis, we were doing the, I would say like the existing or the most typical case now, where actually like the electronic components are typically imported from Asia and from China, but that's not, maybe that's not the ideal scenario. And then we need to have more localized production within Latin America or within Africa for the electronic equipments, where the metals or the minerals are extracted and produced locally and then used to manufacture.
And you know, in my past, because now I'm in finance, but during the 90s, I was in process lines and life cycle assessment and pollution prevention and so on. And I worked with the biggest producer of refrigerators in Latin America that right now is based in Brazil, and it's also it owns MAVE, which is the one that you analyzes. And in those terms, until the 2000s, all the production and all the parts were made in Latin America. So it's at the point of the globalization when parts and pieces start coming from China. And on that point of view, and going for life cycle, and Jasmine, I really would like you to maybe elaborate a little bit more on how it comes and how is the impact of the methodology you are proposing on our carbon cost. You know, I took from your presentation that it's between 69 to 204 US dollar per ton finally. Normally, for instance, in Latin America, the cost is 189. In Europe, it's about 100, depending on the technology. And United States is 100 and couple. So for us in developing countries, the cost is really relevant in our budgeting, in the total GDP of the country. So how could be the impact of your methodology in the whole investment on decarbonization? How can be scaled or maybe transfer as know-how to other areas?
I'm not very familiar with the carbon costs because
parts, yes, I know.
yeah, because in Malaysia there is no price on a carbon, so that life cycle costing that I've done is actually taking the cost of each processes.
Don't worry.
Yeah, and put it into it. But we have a very low cost. It's because of the low material cost and also low labor cost. So that's why it becomes a low cost. But it needs to have some sort of economic like incentives. So if you sell the biochar, you can lower the cost because you can factor in the profit from biochar and lower the cost, overall cost.
And that's why I find it interesting. In our countries, what we have is a gap of technology and investment, and also a gap of knowledge. Normally, we calculate the carbon social cost, which is maybe $40, and the technology to arrive to the net zero will be $200, which is what you calculate. And I think that going into it could really prepare us, developing countries, into implementing maybe solutions that are not perfect, but maybe for us it's good enough to allow economical growth and the net zero. So I don't know if someone would like to come to the discussion and have a little remarks or something. No, we still have some minutes. It's not just me asking questions. Yeah, go on.
Me, I have two questions. One for Loy.
Mhm.
So for you, it's like, so it was electronic equipment in South America, right? Is it mainly second use equipment? And like repair, workshop, and all stuff around, like, let's say, second part of the lifetime of a product? Or is it also like, how is the market? Is it like mainly new equipment used in South America, or is it like mainly second-hand equipment coming from northern country?
So we had like retailers. So one of the companies, for instance, they were producers. They import these electrical equipments from Asia, and then they produce like first-hand equipment. But there were also like recyclers and refurbishers. But we're not looking more like, this is more on a company business management level, not really on a product level. But many of them worked in the remanufacturing or recycling, refurbishing as well. But yeah, mostly the products for the retailers or the producers, they were like first-hand.
Yeah, and if I can indicate also, normally we in Latin America produce first-hand devices, but there is a whole market from Latin America to other countries. So normally, for instance, countries as Chile and Argentina, since they have a better level of life, Chile is 0.848, so we are at the level of Portugal maybe. So we receive a lot of new products to be tested on the market. And after that, they re-export the second-hand products through Asia or through United States to other countries in Latin America and Africa, mainly. Okay? Yes, sir? You have a question? No, you were just moving. You? Yeah?
Thank you, everyone. This question's for Jasmine. In your assessment, did you look into the carbon found within each of the 5 categories? For example, shells would contain most likely a large amount of carbon. So how does that compare then to the benefits of biochar from a carbon capture standpoint? Thanks.
Thank you very much. Okay, I've considered the carbon content. So when I'm modeling my Aspen Plus simulation, I put in the ultimate and proximate analysis of each of the feedstocks, which contains the carbon percentage. So in my assumption here, the carbon will be stable, like 50% inside the biochar, and 80% of it, 60 to 80% of it is stored in the biochar. So for bioenergy with carbon capture, it's a different case because the carbon dioxide is, the biomass is then burned and then carbon dioxide is released, but then it will have to be captured, which is using the MEA, and then also high impacts associated with it because of the energy used in regenerating the solvent. So that is actually reducing the benefits, which makes the impact is higher in BECCS as compared to biochar.
Another question? I do have a question for Tahira. Yeah. Sorry. So, as I told you, I was working like for 5 years in Mexico in plastic recycling. And one of the problems we faced was that the quality of the waste was not as good as we needed for the process. Meaning in Latin America, we tend to use things a lot of times before dumping it. So our plastic coming locally had some challenges in terms of the quality to come into the process. So we needed that American waste, finally we did some kind of agreement to ensure this incoming waste from United States. So we could add it to the mix and improve the quality. Is that an issue for your waste plastic?
So I haven't actually looked at imported waste. I think the waste that we generate by ourselves actually within South Africa is the main material flow. Yeah, I think having said that, we probably need to look at like the definition of circular economy a bit more. And constantly there's this sort of focus, and obviously my research also looked at that, where we generally concentrate on downstream processes and we talk about recycling, but we also have to remember that the real change can only really come up front. So more upstream, looking at, for example, I did the demand moderation, but then also in terms of, design for recyclability. And also bearing in mind that recyclability is not really the end goal. And if you consider the butterfly diagram in the EMF, you'll see that recycling is actually the last resort, basically. So you'd obviously want to focus more on like reuse. So I think concentrating just on recycling as we've done is perhaps we could just change the narrative, I think, to focus more on design and more upstream processes.
Okay, yeah. And on the other hand, the obtention of the secondary resource to enter it again in the process line. So did you explore that already in terms of your research, or is it not, it is not part of your research yet?
So are you referring to basically where you obtain the recyclate and then the collection, sorting, transport, and reproducing?
Yeah,
to some sort of
reproduce, yeah.
granulate? Yeah. So
Use
that
it as a
was included.
secondary,
Yeah.
secondary material.
Yeah, it was included. So I couldn't really point it out, but in terms of your feedstock coming in, it's divided into virgin material. So that's made of local and imported polymer production, and then you also have recyclate. Comparatively, it's obviously a really small amount in terms of, I've just shown GHG, but it's very small in terms of, if you compare it to, for example, local production of virgin.
Okay,
plastics.
because one of the problems we face is that in Mexico, for instance, and in Chile and other Latin American country, plastic is used to package fruits or food in general terms. And we had problems on the public side. So if you have 100% plastic produced to package fruit, this plastic won't be as transparent after as the one produced with full virgin resin of plastic. So did you had some experience on that on your research or not yet?
So the polymer mix that I chose was actually the 7 polymers that are predominantly used in South Africa, and I couldn't actually show the mix. And the recycling rates are also polymer dependent. So I have incorporated that into the picture where, for example, polystyrene would have a much lower recycling rate compared to, for example, PET. That has been taken into account in the analysis.
Okay.
So yes.
Okay, thank you very much. I don't know if you have another question, comment, something, because we have 50 seconds left. No, maybe we can start the second slot. So thank you very much. So on the second slot, we have sorry. I close it. Okay. So we have on the second last slot, Michael Guts, and his presentation is Life Cycles Approach for Biodiversity Impact of Mining and Resource Extraction, combining remote sensing and life cycle assessment. Michael comes from the Zurich University of Applied Science in Switzerland. Thank you. So the floor is yours.
Thank you very much. Can you hear me?
Yes.
Perfect.
No.
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 How do I switch this on?
It was switched on. It
All
is
right.
on. Yes, maybe you can take one of
Yeah.
those and it's easier to move, maybe.
Hello?
Yeah.
Perfect. Yes, hello everybody and welcome to the presentation. My name is Michael Götz. I'm a member of the Life Cycle Assessment Research Group at the Zurich University of Applied Sciences, and I will be talking about life cycle approaches for biodiversity impacts with a focus on the integration of remote sensing data in life cycle assessment. Here you see a collection of some very recent headlines I found during a short web search in business journals and magazines. And it's encouraging to see that issue of biodiversity and ecosystem services impacts of mining and resource extraction is becoming an increasingly present and hot topic. And it really deserves to be a hot topic because human activities such as the built environment, infrastructure, and especially resource extraction and mining puts enormous pressure on biodiversity and ecosystems. These activities are related to land use changes, toxic emissions. We have habitat fragmentation, deforestation, soil erosion, you name it. And here, sustainable private sector investment could be an important lever to address and to tackle these challenges. However, these investments can only be sustainable and not just greenwashing if they can rely on adequate environmental data for assessing these impacts. And this brings us to the current situation where we observe a lack of reliable environmental data. And we have a lack of spatially differentiated data. I'll come to that later. And we have a lack of consistent and comparable commodity portfolio or corporate footprints. We are currently working together with teams from the University of Zurich and the Zurich University of Applied Sciences on the project Spatial Sustainable Finance. These are experts for asset management, geoinformatics, life cycle assessment, earth systems, biodiversity, remote sensing, and so on. The project is pretty early stage, but the goal of the project is the development of the scientific basis to rate companies regarding their environmental footprint and environmental exposure. So what we see today, we have environmental impact reporting, mainly by ESG reporting, which is mainly based on self-declaration and company data. There is still lack of standardization and consistency and comparability of this data. And we often see a lack of transparency or questionable data quality. And here, the combination of life cycle assessment approaches and remotely sensed data could present a chance to provide more regionalized and more independently sourced quickly available data on company or product footprints. So remotely sensed data has the potential to inform and support several stages of life cycle assessment. So for example, it could help with the definition of the scope or the system boundary of the study. And it definitely can improve the spatial differentiation and also the temporal differentiation of life cycle inventory data with regard to land use changes, land occupation, land use intensity, habitat fragmentation, and so on, which in turn would improve the spatial resolution of data, which is relevant for the assessment of biodiversity impacts or eutrophication impacts or ecotoxicity impacts, because other than with greenhouse gas emissions, it is really important where the specific impact occurs. So I'd like to illustrate this with a simple example. What you see here is a screenshot from the fine print global coal and metal mining viewer, which is connected to a background database. Here we are looking at a specific gold mine in the US. And the database, which is connected to the fine print viewer, provides us with the exact location, with the area which is covered by the mine, It gives us information on the commodities which are produced and even on productivity data and ownership data. And now let's say we want to compare gold production in different countries, in different regions, and compare the biodiversity impacts they have. So we can map the specific location of the mines we want to look at, and we can map them to the world's ecoregions, for example. That's what you see on the left side. This is the globe, and color-coded you see the global ecoregions. So for every mine, we could identify the specific ecoregion. In this case, it's again the same mine we were looking at before, and it's located in the Great Basin shrub steppe. That's the ecoregion. And using spatially differentiated land use-based biodiversity assessments on ecoregion level, we can now compare the biodiversity, the potential biodiversity impacts per kilogram of gold, which is produced in the different mine sites we are looking at. I did this comparison using an approach presented by Chowdhury and Brooks. And as you can see, depending on where you produce, where you mine this kilogram of gold, you have pretty high differences in potential biodiversity impacts, not just between the countries, but even within the country. If we look at the bottom three bars, this is all in Australia, but the impacts differ depending on where you are mining this gold. And so you have an increased spatial differentiation. And based on this, you could extend it to commodity footprints, or you could extend it to portfolio footprints or corporate footprints. So this is the concept. Yeah, and this takes me already to the last slide of my presentation. These are the key takeaways. I think we all agree that biodiversity crisis is the most urgent environmental crisis we are facing besides climate change. And mining and other resource extraction activities, they have a huge impact on regarding biodiversity and ecosystems. And what we also see is that biodiversity impacts, they require higher spatial and temporal resolution than we have currently available in most LCA or LCI databases. And remote sensing based data sets, they can be integrated in life cycle inventory and life cycle impact assessments to increase spatial resolution. And they decrease the dependency on self-disclosure of data by the companies. Yeah, that's it.
Thank you very much. Is there any question for you? Yes, you go.
Thank you, Michael. I'm from Canada, and we have a fairly strong oil industry in addition to other mining projects. In this program, is it available to the public? And also, have you thought about incorporating a grading scale for environmental standards of practice so that people who want to invest in mining can know whether or not there are environmental standards taking place at that specific mine, or if there are social and other ecological challenges that come from that particular location?
The data you see here is not our own data. This is from the fine print viewer, and it's connected to the global coal and metal mining database, which was compiled by the Austrian research team around Viktor Maus and Simon Jasanski. And you have information on the type of resource extraction, on the method, how the resource is extracted. But you don't have any specific information yet on any compliance to any standards. Yeah, but that would be nice, of course. Yeah.
Maybe we can leave the rest of the question for the discussion, and next we can pass to next presentation because we are kind of a little late on time. We start after the hour. So now we will be, thank you very much, Michal. We will be having Sanjeeva from the CRPG Indian FSLCL in Germany, presenting her research and integrate methodology to assess environmental, social, and economical impacts. That's it. Thank you, Sanjeeva.
Thank you very much. Am I audible?
No.
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 Okay. Am I audible now?
You have to switch it on.
You need to switch it. Or maybe the other one, I don't know. That's
Okay.
it.
Now it's clapping. Okay, so I'm going to change gears a little bit, taking you away from scientific calculations and complicated formulas. I have tried to simplify the work that we did to be able to explain in a 5 to 7 minute presentation. So my presentation is on an integrated methodology for environmental, social, and economic. And I will focus more on the macroeconomic aspect because that is something that is slightly different from the kind of environmental analysis and results that we see from LCA studies typically. So the context is that nowadays we talk of circular economy and we talk of bringing resources back into the economic system. And we want it to be a win-win situation. So we gain both economically and we gain environmentally so that there is no negative fallback of the actions that we take. And the starting point here is the presumption that for products like apparel, because my case study is in textiles, for products like apparel, we want to increase the utility of garments and we want to reduce consumption of garments. We already know that textile industries among the high polluting industries, about 8% of the carbon emissions are coming from textiles, more than 8% now. And the global value chain is very complicated. So cotton is produced in one part of the world, production happens there, and then consumption happens in different countries with different kinds of consumption patterns. And then finally, when the end of life disposal comes, then statistics show that very little of it is recycled back into fiber and most of it is dumped, especially in the developed countries, most of it is dumped into landfills. And oftentimes, even garments with price tags still on them, never worn, are also going into landfills to some extent. What is the extent of the problem? Of course, it will depend from region to region and how far we can increase the recyclability of garments. So the concept is about bringing resources back into the value chain through elimination of waste. So we're not trying to downsize anything. We are trying to look at how the waste can be recycled, and therefore the scope of the work, this research is that way pretty narrow. We are not looking at the entire value chain. We are looking at what is wasted and what is going into dumps. How can that be brought back? So the theoretical premise for this is can be divided into 3 parts. One is, let us say, for example, we target reducing the consumption by half. So fresh purchases, if we are wanting to reduce them by half, by implication, fresh production will also be reduced approximately by half. And again, assessments can show us that environmental impact will approximately be reduced by half, could be a little more or less. But broadly speaking, we're trying to halve that. So by implication, we are trying to double the utility of a garment. So if it is worn 5 times in its lifetime, maybe we take it to 10. And then see what is the total impact on the economy as a whole. Because one of the main objections against reducing fresh production is that economies will be downsized and the total economic gain or the employment, income, etc., at a macro level will go down. Now, individually, different industries may be impacted differently, different companies may be impacted differently, but on the whole, the macroeconomic environment is adversely impacted if new production goes down. In order to explain the concept very quickly, potential wears is the total number of times a garment can be worn, and actual wears is the actual number of times it is worn. And then there are wasted wears. So potential wears minus actual wears will be equal to wasted wears. And when we talk about bringing resources back and bringing garments back into the recycling and increasing the utility, then we are talking about increasing the number of actual wears. So currently, if the actual wears are X, we would like them to be in the future to be 2X, and therefore calculate all the other implications on how the economy, etc., would be impacted. Why is it stuck on Einstein only? Can you please help me? It's not moving. Oh, okay. So it has gone. It's gone too fast now. Sorry. I'm so sorry. Yeah, it's been like, yeah. Okay. Sorry, I moved too fast probably. Okay, so part one of the case study, it's a current situation and it is an actual example of a city in India. The city is Chandigarh and it is among the wealthiest cities of the country, very well-planned city, and comparatively the population is highly educated, wealthy population. And it's the story of a good quality casual wear item that sells for about $20 in the international market, around 2,000 Indian rupees. And the product is made for casual wear. Some of these assumptions you might like to question whether it can stand 30 washes or 40 washes or 20 washes, but those changes will obviously impact the final figures, but we can still look at the policy implications of these things. So about a year down the line, it is normally recycled as a cleaning cloth. That happens in India, it will never be straight away dumped. So we'll use it as a duster or something for about a month or 2 months, and then finally it will go to the door-to-door collection system. And currently, if we take the typical collection system, it is done in this manner through an NGO with motorized vehicles. So if we take this kind of a model to calculate the current environmental impacts, we'll get an answer on what are the emissions and what are the impacts of production and the end of life treatment. Primarily when we are looking at bringing them back into the fold, then we are going to change the end of life part of it. The production, etc., is going to go on as before. So in the future, we want that the garment should be worn double of its time. So there is this concept of end of use versus end of life. We normally have end of use of the garment much before the actual end of life. And that is what we are trying to do, extend the end of use, because we cannot extend the end of life. But increasing the number of actual wears will increase the end of use of the garment. And typically, when I was a little child, we never had this problem of excessive clothes in our closets, because we would periodically, my mother would sort them. And we used to have these hawkers visiting house to house, and they would bring some steel utensils or some other knickknacks that were of interest that we wanted to buy, avoid a trip to the market, and exchange our old clothes that we are not going to wear. And some of them might be as good as new, which would be recycled by them, repaired, and sold to other potential customers. Now, of course, that kind of thing doesn't happen, but still in some of the smaller towns, it is going on. In Chandigarh also, there is, in the periphery of the main city, the downtown part of it, it still goes on. So if we were to conceive that kind of a system, which is more localized and which is looking at non-mechanized methods of bringing potential wears back into the fold. And some of these statistics are based on what the actual habits of people in those areas are. Of course, city to city, it will be different. And 80% of the goods that these hawkers who earn a living through recycling of used garments are spent on other goods and services within the city. So that is a macroeconomic concept that if we are generating income, then it is not the direct income, it is also indirect income that is generated on other goods and services. So those of you who've used input-output tables for life cycle assessments would understand that it is not just the final product, it is also all the products that go into it and all the consumption patterns also. So theoretically, what we are talking about is national income and population growth is the overarching principle that is happening in most developing countries and emerging economies. The population is growing, the prosperity of the population is growing, and consumption is going to grow. There is no way that we can stop the consumption from going, and there is no way we'll be able to control the impacts of fresh consumption unless we are able to change the future consumption patterns. So this case study is not based on changing current habits. It is based on being futuristic and looking at the emerging middle class in developing countries and trying to put in habits in place that kind of preempt the environmental impacts rather than struggle with current habits, which is going to be a very difficult proposition. So we have the current UMC consumption. UMC indicates upper middle class, where the wealthy have unused clothes lying in their closets. And then there is the aspirational lower middle class that is going to come up in the future in the next, say, 2 to 5 years and increase the overall consumption volume. And yeah. Yeah, I'm sorry for the slides jumping. And the current upper middle class consumption, because there is a lot of wasted wares lying in the closets, there is a financial cost to it, but the upper middle class doesn't care because they can afford it, so they are not going to worry about encashing that. And the future lower middle class consumption is going to grow exponentially, and that is going to cause a lot of environmental impacts, which is what we are looking at preventing. And diverting the wasted wares to lower middle class future consumption is what the whole idea is, and to assess how the macroeconomic scenario will be changing with that. To keep it simple, we're not looking at the resources that get freed up by diverting future production elsewhere. And depending on the diversion mechanism, so how this recycling process is done, if it is mechanized and uses equal amounts of energy as fresh production, then of course there's no point in doing it. So we have to look at what the mechanism is, and probably on a smaller scale, city by city approach might be something that will not have net negative impacts. So if there are no burden shifting impacts from the recycling, then only this kind of a process is useful. Otherwise, there's no point. So in order to look at the economic aspects, we need to see what is the multiplier effect in that particular area. I will just quickly go to the financial numbers. So the role of environmental analysis will be to figure out what should be the targets. So LCAs can probably tell us whether we should look at targeting half of the consumption, or we should look at targeting 1/3, or maybe more than half, whatever. So a life cycle assessment can help us, the environmental analysis, whether implementation of this strategy is going to make any sense or not. If we find sense in that implementation strategy, then only we go to the changes that we need in the procedure, processes, etc. for recycling. And very quickly, this is based on actual demographics of Chandigarh, the number of wealthy households, the population. So if we were to consider different scenarios, so how many t-shirts, for example, in a wealthy family are bought per year? And that is the kind of scenario our research indicated. Some people are buying, say, about 50 pieces of casual clothing, ranging up to from 50 to 20. So this scenario shows us at the end of it that the purchase price of wasted wares is $3.7 billion if we were to count the entire population. So finally, if we are looking at avoided purchases, those are the kind of figures that we are coming up with based on the population and the circulation. Okay, yeah, sure. I think we can keep more explanations for the remaining part.
Yeah,
of the
so
discussion.
thank you very much, Sanjita. So maybe we can go directly to the last but not least presentation, and then we will have 15 minutes of discussion. Please save your questions. I have 2 of them already. So now we have Silvana Loaiza from the Reykjavik University in Iceland. She will be presenting life cycle assessment for select Blue Lagoon skincare products.
Hi, good afternoon. My name is Silvana. I'm going to present a life cycle assessment for selected Blue Lagoon skincare products. This was part of my master's thesis carried a year ago. This is an LCA applied to the industry to inform decision-making for the optimization of processes. So first, I would like to explain the geothermal system play at the Reykjanes Peninsula in southwest Iceland. There is a heat source very close to the surface, and the surface is a layer of porous lava rock where seawater as well as rainwater pour to form the water source that is then heated by the heat source, and it can be extracted to produce energy, electricity, and heating. The first geothermal power plant was built in 1974. The Svartsengi geothermal power plant was extracting the source from 2 kilometers in the from 2 kilometers deep. And after producing energy, the leftover brine was dumped in the environment, causing a disaster. A few years later, in the early 80s, some adventurous neighbors were starting bathing in this disaster that is now called the Blue Lagoon. And they discovered it has medicinal properties, mostly to cure psoriasis. So the Blue Lagoon was built in the 90s. The resulting brine as a byproduct is not only used to feed the Blue Lagoon operations, but it's also used to produce silica, salt, minerals. It's also used for the cultivation of blue-green algae that is also fed with CO2 produced by the geothermal power plant. So it's a carbon capture system. All of these byproducts generate a higher value of this resource, and this increases the creation of local jobs and the development of production of a variety of skincare products. So why conducting an LCA for this company? For the skincare products, there is still a complex transportation logistics. Most of the raw materials are extracted in Iceland, but they are packaged and they are sent to Europe, mostly to Denmark and France, where they're packaged and resent to Iceland and to the rest of the world. So there's a desire for this circular business model to create, to optimize resources, and a hotspot analysis by applying LCA is used to improve the production performance, looking to reduce energy, water consumption, and waste production. So the objective is was to perform a hotspot analysis by applying LCA into different scenarios, how it is currently produced now outside Iceland. And the second scenario is what the environmental impacts would be if they were produced in Iceland. A life cycle assessment was carried out aligning to the ISO 14040 and ISO 14044. It was modeled in Gavi software with the Invent database and recipe 2016 midpoint. Some limitations of the study were the data gaps. It's very difficult to trace the other raw materials production and the whole life cycle of these materials, and also time constraints. So the functional unit is a 5-time use of a natural skincare product sourced in Iceland to keep the skin healthy and moisturized. This is a 100 milliliter silicone mask. This functional unit allows the further comparison between reference flows. On this study, multiple comparisons according to, I'm going to explain 2 modeling scenarios from cradle to grave. The first is as it's currently produced in Denmark, and the second scenario is the complete production in Iceland. The system boundary considers from the extraction of raw materials that are the byproducts from the geothermal power plant. The geothermal power plant was not included in the scope, and it includes the product processing, the transportation, use to the end of life. Results show that transportation is the major contributor, followed by packaging and extraction and production of raw materials from the ingredients. Here, in this scenario analysis, it's clear that producing in Iceland reduce the overall environmental impacts in all the categories. Besides the freshwater consumption that increases by 24.35% due to the energy production in Iceland based from geothermal and hydropower. So producing in Iceland reduces global warming potential by around 14%. It increases freshwater consumption by 25%. But reduces terrestrial acidification by 21% because all the transportation has been reduced and the system is less complicated. A sensitivity analysis carried out for the packaging shows that the use of HDP in the cups, if it was reduced to at least 10% of the quantity that they use now, could reduce also overall the environmental impacts in all categories. For example, the global warming potential could be reduced to 12%, up to 12%. And what has happened after a year of this study is that the packaging actually changed. It reduced the use of plastic by 94%. So the new packaging is now made from aluminum that is recyclable, and it doesn't lose its quality properties. And the HDP used for the cups has been reduced to less than 10% than what was used before. So the conclusions of this study are first that the complete product system was defined. No one in the company knew the whole life cycle of their products. So it was a bit of researching inside the company and getting all this information to create this complete product system and understanding the life cycle. The LCA was indeed effective to inform decision making. Nevertheless, it is more efficient to conduct LCA during the design phase because you can lower environmental impacts. And of course, LCA only focus on the environmental side cannot be used for decision making. It's also needed further research on the on the social aspect and the economic aspect to make a better decision making or more complete. Thank you so much. And if you have any questions.
You can stay over there. Oh, I go there. So we can have our 15 minutes of discussion. Yeah, we have time. Do we have some questions? Yes, go on.
Hi, I'm Carl from Equinland. This quick one for Silvana. Hi, pleasure to meet you in person.
Nice to meet you.
just since you pointed out the freshwater consumption, this was not regionalized in the recipe midpoints, but freshwater is hardly scarce in Iceland, right? So
Yeah, actually, the specific case of Iceland, that this might be a lower result because they are counting the evaporation on the dam sites of the hydropower plants, but I don't think there's much evaporation in Iceland. And well, the geothermal production and the water in the cooling tanks.
Yes.
Hi there, I'm Nicole from the London Metal Exchange. I have a question for Michael. So on the measuring biodiversity impacts, are you able to differentiate an impact that's happening due to the mine specifically or something that's happening, regionally? Can you make that differentiation in your work?
You probably cannot make it based on satellite imagery. Maybe you can analyze the impacts on the near surroundings, but you hardly can analyze effluents which are somewhere downstream from leakage or something like that. But for that, you could use the life cycle inventory data you have on different production methods and mining methods. But no, you cannot capture it with satellite imagery. Yeah.
Thank you. Do we have more questions? Everybody wants to go and have lunch? No? You have a question? Okay.
yeah, maybe one for Michael as well. We've looked into remote sensing as a source of data, but to operationalize it in LCA, we also need to put it into reference to what is actually the output. And how have you dealt with that in your analysis? Do you find good data on what is actually being produced in terms of functional output at the sites? And maybe also how you deal with co-production where it actually needs to be attributed over many output streams?
Very good question. Thank you. As I have said, we are still in the conceptual phase and we are developing case studies right now. And the database I showed, you there have differentiation between different commodities, and you have production volumes for each commodity which is produced by the mine. So you could do allocation, but data quality and data availability is a huge topic because this open global coal and metal mining database, it includes maybe 1,000 to 2,000 mines, and it doesn't cover all the mines. So there is a lot of work to be done when it comes to inventory data and mining data and supply chain data, also when it comes to data regarding ownerships. And yeah, of course, this is a huge challenge also within our project.
Do we have another question? I have two questions. So I promise it will be short. For Sanjeev, for me, it's really interesting, the approach. I think we share generation. So we're from the time that people didn't have a lot of things, that 50 pair of shoes or a full closet of clothes. And right now we face fast fashion with medium class people rising and wanting to live the world we sold them in terms of what's the meaning of having a better life, meaning being able to buy stuff. And in my country, we have a big desert, Desierto de Atacama. And close to the desert, we have a free port, meaning no income taxes for imports. So we are receiving full containers of fast fashion with prices in it being dumped in the desert. So how do you think we could face in this economical approach, since these movements of really importing waste to countries, to third world countries, from probably big north of this fast fashion? How can we deal with it?
I think if we put the economic hat then it is all a question of demand and supply.
Mhm.
Because in the developing countries, if there is demand for second-hand clothing or maybe new clothing or fast fashion, then there are going to be pressures to get that kind of stuff into the country. If that pressure is low, demand pressure is low, there are alternative means of meeting that demand, then that pressure can be cut down. So obviously, if there is no demand, then why will things be coming into the country? If there is demand, things will come into the country this way or that way. The whole approach, the macroeconomic approach, coupled with the life cycle assessment for environmental impact, is meant to be sold to the policymakers. So if the city's economy is going to benefit by $3.7 billion just by channelizing the wasted wares lying in the closets of the wealthy, then it is something that appeals to the policymaker. And at the same time, we are reducing environmental impact that is going to come with rising middle class population.
Yeah.
So how do we channelize that demand is the question. And that is where the policymakers' role comes in. How do we have campaigns? How do we have mindset changes, etc., that we talk about? It is easier to change mindset for future consumption rather than for what is going on right now. So managing demand is, I think, the key
point. And for me, I've been working in life cycle assessment and on biodiversity. And I've been using other approach like metagenomic analysis, which is analyzing the DNA on the soil you can, and water and so on. How do you see your approach, like remote sensing, maybe getting part in data, available data on baselines, basically, with these other methodologies? How do you think they could work together, or do you think a complement?
I think they have to be complementary, because you cannot assess biodiversity as a whole just by satellite imagery or time series of satellite imagery. Of course, you have to look at other indicators as well, and they cannot be covered or informed by drones or satellites.
Yeah, of course. Okay, so if there is no any other question, we can, yes, please.
I'm Stephen Nolly from University of Technology, Sydney. I guess I'm just curious, like in India, are people really buying 50 pairs of shirts a year? Is that, are there good statistics on those sort of things?
Yeah, the upper middle class, where the income levels, according to the income tax slabs, are more than 10 million Indian rupees a year. And 50 means what? One a week?
Which is not
every
much.
Sunday.
No, I promise myself that I won't be having more than 50 pairs of shoes and 15 pairs of boots. So I can tell you, one can have 50 pairs of shoes and being happy with it.
Buying one piece, one garment a week.
Yes.
Every Sunday you go out buying just one piece.
Yes.
And the city chosen is Chandigarh, a wealthy city, because these kind of things would fly in wealthy localities, not in all kinds of localities. So when we talk of circular economy, bringing resources back, then we have to look at what geographical area are we talking about. So one of the key points, I couldn't go into all the assumptions because of time constraints, despite the fact that I overshooted the time. The issue is that it is very easy to talk about circular economy, but what is the net impact of these kinds of strategies? We have to look at, before we recommend some strategy, that this is what we want to do, we have to look at the geographical context also, and what will be the net impact. Again, we don't want burden shifting. Instead of doing this, we do something else and cause the same impact. So yes, but
Yes.
to your question, yeah.
Yeah, just a remark. I think just a pity that we are looking for circular economy in the country. We have not so much problem, and the big problem we have in developing country. If we see with the clothes, you have some. You can command clothes per post. You become 3 houses. You try and you keep one and to send back, and these are no more sell. They are throwing away because it's too expensive. And so I think we have to make much more effort in developing country, and not to give lesson to developing country which has less problems than us.
Because of course you have in developing countries all the expectatives, meaning sentences like, we have the right to develop, we have the right of buying things, we have the right to rise to a certain level of life. So it's complicated because there is also cultural issues. So I don't know, maybe.
If I can
Okay.
just quickly add,
Yeah.
the biggest nightmare is that if developing countries in the near future achieve the same consumption patterns, then where is it going to go? Because the populations are so huge. If we were to have the same per capita footprint, I mean, it will be very quick destruction.
Plus, we are not as efficient as Europe in the GDP production. For instance, for the very same ecological footprint, for instance, my country produced $51,000 per worker. France, at the same ecological footprint, produced $90,000 per worker. Paraguay, where I'm working right now, produces $17,000 per worker. So if we, at the same efficiency of use of resources, start growing, we will have a nightmare. Don't forget that Europe is just like OECD certified countries. There is 194 waiting for developing. So it's important to focus on developing countries and how they are growing. So thank you very much, everybody. Don't forget to vote for the presentation you enjoyed most at the AWOVA. I think we have the voting for the session. So thank you very much. See you.